I want you guys to take just a minute, read over the introduction to this problem. Mark this problem up. Make sure you understand it. I want you to do all the things you're going to do the day of the exam to really wrap your brain around it. We'll talk in a minute. Yes. It has been a while since we have done problems like this. Back in like September and October, we were doing these all the time. Right, and one of the biggest mistakes that was happening, too many times, is people not paying enough attention to know what graph you're looking at. David, what graph is this? This is the graph of G prime. This is important that you know what graph it is. All right, so let's get some hands on this. Part A, let's see. We know G is continuous. We've got G of 2 is equal to 5. Great. Fancy word for G of 2 equals 5. Wait, what's a name for this? It is a coordinate, but we call it something else. It's the only point that they've given you. We used to call this the initial condition. It's like your, yeah, thank you. Okay, that's your initial condition. Great. All right, graph is a piecewise linear function. G prime is shown above. Great, G prime. Find the x coordinate for points of inflection. Let's get some hands on this. Point of inflection. What do you do? You've got your survival guide, you've got the summary sheet in the front. Use the resources. Use the resources. Juan, what are your thoughts here?
It has to be a point where changes when gravity happens.
Okay, I heard you say something. It's been such a long time. Can you say that one more time?
When the function changes gravity.
Right. What I don't want to hear, especially now, is this word "it." Right. This is lethal. So if G has a point of inflection, Daisy, what do you know?
It has to change from increasing.
This is where we're going to be careful. G has a point of inflection.
Oh.
If this is the graph of G prime, this is the only thing we can actually talk about. So talk to me about G prime, Daisy.
It has to go from positive to negative.
G prime has to go from positive to negative. Are you sure about that? If G has a point of inflection, go back and look at that table. G prime.
Increasing to decreasing.
G prime makes a change from increasing to decreasing. Mariah, how do you feel about that?
Or decreasing to increasing.
Right? You actually have to get both of these on the board. If G has a POI, G prime changes from increasing to decreasing or decreasing to increasing. Got to get both. Abraham, where does that happen? Okay, at 1, 1. Now there's something, it's been a while. If you read the opening statement really carefully, they want the x coordinate. Just the x coordinate. So Abraham, I'm going to ask you that question again. What's the x coordinate for a point of inflection? Where does G prime change increasing to decreasing? This is going to happen at x equals 1. And Jennifer, where does G prime change from decreasing to increasing?
X equals 2. I mean, not 2. 6.
6. Now, why are you focusing on 6? I'm asking the question about G prime changing from decreasing to increasing. One more time. Where does that happen? Where does G prime change? Decreasing to increasing. At x equals 4. Okay. Now, if I'm scoring this like the college board, most likely this chunk of information over here would earn you 1 point. This chunk of information over here would get you a second point. We're on the board with 2 points. But if you don't mention G prime, if you use the word "it," you throw those points away. Okay? All right, B. Find the absolute maximum of G on the interval. There's two flavors here. There's two flavors of max, and it's been a while. One flavor, relative max. Another word that they use for relative max up here? There was relative max, and then they also used the phrase, begins with an L. Local. You have relative and local. Those are the easy kinds. Then you have absolute max, also known as global. Which one are we looking for here? Global. The global, the absolute maximum. These are always the hard ones. These are always the hard ones. Okay? So, have a quick strategy conversation with somebody near you. What are you going to do?
We got table.
Oh, I saw that too. Oh, you mean that?
So from circling the three groups, like all the right ideas are there, right? Absolute max. I heard the first word, candidate, right? I need a candidate. My candidate for an absolute max, right? When I say candidate, what am I really saying? I'm saying where does G have a G, or G has a relative max? Christian, what is? Or, sorry, I'm so used to Christian being there. No, wait, what does it take for G to have a relative max?
Change from increase.
If G has a relative max and G prime is what you've got.
From positive to negative?
G prime changes positive to negative. Rambir, where's your candidate?
Right at 1, x equals 1.
At x equals 1, that's where G prime changes positive to negative?
Oh, I'm sorry. No, I'm sorry. At 1.5. Is that
One-
2?
No.
I'm sorry, that's 2.
Okay, we're going to get you there eventually. Is everybody okay with 2 being the candidate? 2's not the answer. 2 would be a, what kind of max?
Relative.
Relative max, also local max. X equals 2, relative max or local max. But I want an absolute max. David?
Running absolute max, you have to first check out the endpoints.
Right now, we've got to go look at those endpoints. We've got endpoints here. What are those endpoints?
-3, 7.
Right, -3 and 7. We know what the candidate is. We know what the endpoints are. Like, the hard part now is like, you got to start organizing all this information and taking some action. And I heard it at all 3 groups. It was like the thing that worked so well for us. You guys would like make a table of values. And over here you'd say, okay, here are my x values. My x values are 2, 7, and -3. The function, what's the function that I'm evaluating, right? The function that I'm trying to maximize is going to be g of x. And so you've got to tell me what's g of 2. That's easy.
5.
G of 2 is,
5.
thank you. Right, g of 2 is 5. That's the initial condition. Okay, not the easy question. And I want you to think about this before you say anything.
Oh.
G of 7. G of 7. Where is G of 7 going to come from? You don't have a graph of G. You have an initial condition and they gave it to you for a reason. Jasmine, my birthday girl, what are your thoughts?
Is G of 7 0?
Is G of 7 0? No, where are you getting that from?
The initial equals the final maximum.
Where are you looking at the graph over here?
I am.
I'll tell you, looking at this graph to figure out G of 7, not a good idea. Why? Daisy, why?
Because it's G prime.
This is G prime. You are not going to know what G of 7 is from this graph. You're going to need something else. Who's got it? It's been a while. I see you. Anybody else? There was something that you used to do. You're trying to find the value of the function at this point, but you know the value of the function at one other point. And you have derivative information. Rambir, what's the thing?
Don't you calculate the equation of it?
It's not that you're looking for the equation of a tangent line. It's been a while since we've done this, so the fact that we might be rusty, not a surprise.
Equals
not the slope. You know the value of the function at one point, you need the value of the function at another point. What I was hoping that you guys would remember is the fundamental theorem of calculus, which says that f of b equals f of a plus the integral from a to b of f prime of x dx. The way we used to talk about it, we'd say the value, like the final value, equals the initial value plus total change. Or you could say the value that I need equals the value that I know plus how much the function changes. So in this example, we'd say g of 7 is going to be g of 2 plus the integral from 2 to 7 of g prime of x dx. I would definitely put a little star next to this one. Fundamental theorem of calculus, it's going to start showing up a lot, but it hasn't in the last couple of units. So g of 7 equals g of 2 plus the integral from 2 to 7. Well, g of 2, I know that. 5. Now I need the integral from 2 to 7, g prime of x dx. Friends on the left side of the room, thrilled with 3. I want to know the integral from 2 to 7. David, what are you going to do?
We go to the graph.
You're going to go to the graph.
Shaping all the sides of the graph, so then you can calculate.
Right, here's 2, here's x equals 7. When I say find the integral of g prime of x dx, what I'm really asking for is area. Okay? Finish it off here. I need you to find g of 7, and I want you to find g of negative 3. We'll talk in a minute or two.
If I know the rest, you're big enough.
Can we say that credits dimensional from the g prime changes from positive to negative? That's what we said, right? Right, but if we're trying to find candidates, so why did he get 1? That's changing from, I thought it was B. You got 2 for here. I don't know, that's what I'm asking. Like, there's 2 more. Why would he get 2?
From G.
Oh, wow. He doesn't know what that is.
Yes, he does. Like, you have to figure it out.
Doesn't make any sense.
You can figure out the points from going, like, you have to figure out what you used to do.
How does that make any
You can
sense?
find
That's 2. Alright, so I'm pretty sure the area for this triangle, negative 4. Okay, area for this triangle over here is going to be a half. So if all goes well, I'll get 5 minus 4 plus a half, which is 1.5 or 1.5, any way you want to go for it. G of negative 3, G of 2 plus the integral from 2 to negative 3. This is where we're going to make the mistake. Number 1, like, don't get worried, like, why is the 2 on the bottom? Because 2 is your initial condition. It's the one that you know. The final equals the initial plus the total change.
Don't we make all the area negatives since we're going backwards?
Right, because you're going backwards, you're going from big number to small number, your options are to say, oh, I'm going from 2 to negative 3, so I find my area taking the opposite signs, or the other option. There was another thing you could do here. The other option involved changing these limits of integration. You say, let me put the negative 3 in the bottom, let me put the 2 on the top.
And then make everything negative.
But then you're going to go and make everything negative if you're going to change your limits of integration. Either way, same answer. Right? We're just going to say it's 5 minus. What's the area from negative 3 to negative 1? Let's see, the length there is 2, the height here is 4, base times height, cut it in half. Negative 4. Area from here over, base is 3, height is 1. Area is going to be 3 over 2. 5 minus negative 4 plus 3 over 2. If I distribute the negative through and simplify, I think it's 15 over 2. Edgar.
So we had said that to find like a maximum, g of x has to change from positive to negative, right?
That's for your candidate. Wait, did you say g has to change positive
G
to negative
prime.
or g prime?
G prime.
Yep.
So then, why didn't we use -1 or 6?
Why didn't we use -1? And why did we use 6?
If they're changing from.
So we're looking, why
Oh,
did we
it's
use
negative.
-1 and 6? Why did we use -1 and 6?
Oh, it's negative positive. Sorry, that's a minimum, right?
Okay. Is everybody okay with the values? Answer to the question is what then? Hold on,
Oh, we're
Jasmine.
doing this.
What's the answer to this question?
3. -3, sorry. Next to
Everybody agrees with -3?
15 over 6.
Then no one would earn the point.
That's 7.5.
Go back and read the problem. You've just done all this work. Don't throw the point away. Find the absolute maximum of g. What is the absolute maximum? I could either ask you where is it, or I could ask what is it? What's the absolute maximum?
7.5.
Right? Therefore, the absolute max is 7.5. Jasmine, it looked like you had a question earlier.
I got it.
You got it? Okay. I really care about B. B is probably like a 4-point question. Okay, my fighting for a 5 folks, we're gonna switch gears in just a little bit. Part C is the last one that we have time to do as a group. I'm not gonna have you do part B. Just take a little bit, look at part C, have some conversation with somebody near you. What are you gonna do?
Don't you use something fun?
Slow. It's already slow.
No, but our average is like, just suppose you know, your graph is, our graph will go all the way up here and down, all the way but the average, it wouldn't say.
Oh, you know, yeah.
Eavesdropping on the conversation.
So, I don't know why I think it's fun.
Average rate of change. You guys know this by another word.
Slow.
Not derivative. Slope. They're asking for average rate of change, AROC, on this interval -3 to 7. Right? The way you would know derivative, they would say instantaneous. Like, what's the change at like a moment? They're asking for average rate of change. Well, the way you used to find average rate of change back in the day, right? Rise over run, change in y over change in x. This is not y and x. I want average rate of change of g. So g of 7 minus g of -3. 7 minus -3. That's how you'd find average rate of change. G of 7, we've already figured it out.
5.
G of 7, what is that, 1.5? Or 3/2 minus the other one, 15 over 2, divided by 7 minus -3. And shame on you if your OCD is taking control here.
Oh,
What's 3 over 2 minus 15 over 2? No one actually cares.
Leave it.
If you know it's -12 over 2, if you simplify to -6, great. 7 minus -3 is 10, sure. But you earned the point here. The only thing you can possibly do, Daisy, by going to -6 over 10 is throw away a point that you just earned. Please don't do it. Okay. All right, that went a little bit longer than I wanted to, especially if you're like checking my lesson plan back there. My thrilled with the 3 group. You guys have the next 10 minutes. You're going to move over to that side of the room to get started on tonight's homework. Tonight's homework is 10 multiple choice questions, all having to do with F, F prime, F double prime stuff. Okay? Due tomorrow. Do not worry about the free response questions. 10 multiple choice questions. I have to see your work. My Fighting for a 5 group, you're up next. Come on over with your calculator. And Mr. T, you're going to have to move because Marvin, you're driving.
Do you think I go to the restroom?
In 10 minutes? Absolutely. Great question. Thanks for asking. If you're like DEFCON 5, sure.
I'm loaded.
Good thing you're full grown, Edgar. You can make it for 10 minutes.
That's just right. Good job. I'm glad to know y'all was fighting for our.
All right. Giselle, we're good? All right. So, Fighting for a 5, folks. How'd that last question go?
Okay.
Maybe you weren't quite fighting for a 5 as ferociously as you were hoping on this last one. It's been a while, but honestly, like, I want to make sure you guys are always getting some time to just dig in and see what you can do. There are going to be days that go better than others. Okay, we're going to do this one question from the 2010 exam. My goal is that we're going to be able to get through A, B, and C. We're going to go fast. You need your calculator. Marvin, you probably need me to log in, right?
Can you give me my calculator for a minute? Oh, gracias.
Okay.
Did you ever find out who calculator that was?
Yes, thank you for asking. Okay. You guys over here, everybody's working on homework, right?
Yeah.
Edgar, you good?
Yeah.
Okay. If you guys could be in whisper mode, that would be good, because it was animated, it was great. Friends over here. Okay. So, things that we know about this problem so far. I'll take anything from anybody. What do you know?
We know the derivative and
They
the
gave
second
you derivative
derivative.
information. And they gave you second derivative
And an
information.
initial condition.
And they gave you an initial condition. Good word choice. Okay, Christian, what was question A asking?
Find all values of x in the interval 0.12 less than or equal to x that's less than or equal to 1, at which the graph of g has a horizontal tangent line.
Okay, horizontal tangent line. 2 points available to you if you can answer this question. She has a horizontal tangent line. Have a quick strategy conversation with somebody near you. What are you going to do?
Well, yeah. Can we say? Cool.
Right here, I really need to focus on this side. All right, Eunice, Eunice, hello. Adriana, what are your thoughts here?
The derivative of g
Yeah.
will equal 0.
Okay, derivative of g is equal to 0, and it's not, I think most of you guys already said, like, horizontal tangent line g prime is equal to 0. Great, 1 point. Jonathan, what's your next move? How are you going to figure out, Jonathan, where g prime is equal to 0? You're going to graph g prime. You're going to find the zeros. That's it.
Woo.
All right. So Marvin's going to get me a good graph. Now some wonkiness is going to be coming your way. Okay, but I need you to find the roots. So, Marvin, I think you're about to run into some problems back over there. You need to change what? You want to change the zoom settings. Specifically, you want to change it so that it matches the domain restriction, right? They only want you to find the zeros between 0.1, 2, and 1. So I would do menu, window zoom. Oh no, menu, window zoom. Zoom settings, because you need to take control of the window here, Marvin. Oh God, Marvin. Window zoom. Settings. There you go. X-Min and X-Max. Gonna find the roots. And if all goes well, how many roots are we finding?
2.
2. Martia, where are the roots?
0, Ix equals 163.
0.163, that's one of them. It's better make sure that you're accurate to 3 decimal places. And?
0.359.
And 0.359. Are they both in the interval?
Yes.
Okay, how many of you guys came up with both of those roots? Perfect. That would get you 2 points. Done. Love it. Marvin, how's it going back there? Okay, B, Adriana, what's the question in B? I forget now.
It says on what sub-intervals of 0.1 to 1 is the graph of G concave down? Justify your answer.
G concave down. What are the thoughts that are out there? G concave down. How would you ever figure out where G is concave down? I see one person. I see 2. G concave down. I see 3. Giselle, what are your thoughts here?
That the derivative is decreasing.
Okay, one way would be to say where is G prime decreasing? Martyr, what's your other way?
G double prime is negative.
Okay, G double prime is negative. Either figure out where G prime is decreasing on the interval or figure out where G double prime is negative. Does not matter at all to me which one you're going to go with. But let's be smart about this. If I already have a graph of G prime in front of me, why not use that graph to figure out where it's decreasing? And we've only got a couple of minutes left, so if you guys don't mind, we're gonna skip the actual finding of the points, because that's just some calculator skills that I think we're all good with. All right, the one I think we're gonna close out today with part C. Part C. I need the equation of a tangent line. All right, equation of a tangent line. Kimberly, what are the thoughts that are out there? How are you going to find the equation of a tangent line? You need the derivative for that y. So you have slope. So you need the slope. You can use the derivative for that. The other thing that you need? If I want the equation of a tangent line, you need slope and target and Charlie. No, that's not how you're going to write the equation of a line.
You need G, where
You
G
need
is
slope
0.3.
and a point. You need a very, very specific point. The slope is just going to be G prime. Is it 0.3?
Mm-hmm.
Chris, did you get G prime is 0.3? Or not yet?
I got negative 0.7, 4721.
The negative 0.4721. Eunice, you got negative 0.472? That's the slope. Great. But I also need the point. What I know is that the x-coordinate is 0.3. The y-coordinate is going to be G at 0.3. How the heck are we going to figure out G of 0.3?
And this,
Okay, if you guys could give me just 1 second. Okay. Friends on this side of the room, 10 multiple choice questions. due tomorrow. I'm going to stay until 5:30. If you want to stay and work, that's great. Friends on this side of the room, just one more minute. The big question is, where am I going to get G of 0.3 from?
Fundamental theorem of calculus.
Right, if I need G of 0.3, and all I know G at one other point. I know G at one point, I need G at another point. We're going to go back to the fundamental theorem of calculus, and this is going to say G of 0.3 was it G of
1.
G of 1. So G of 0.3 equals G of 1 plus the integral from 1 to 0.3 G prime of x dx. Right, the point that I need equals the point that I know plus the total change. All I need you guys to do is give me the numerical value and then tell me what we're going to do from here.
Put it into an equation. Whatever you can.
Right. G1 is the y value that you got.
2. Yeah.
Need the number value. Marvin, you look like you're dying back there on the laptop. Ah, there you go. 1.546. Oh, you weren't dying. You had worked ahead and you were hiding your answer. Thank you. Adriana, what's the question?
Wouldn't that have to be negative? Minus the interval from 1 to 0.3?
The fundamental theorem of calculus says f of b equals f of a plus the total change from a to b. If you're going to put this guy here at the bottom, it's plus. I think what you're thinking is, but wait, I want to put the small number on the bottom and the big number on the top, and I want to change it to negative. That's fine. Okay? The y value is 1.5467. Okay, final answer, equation of the tangent line. What's that going to be?
Yeah, L of x is slope.
I need slope. I need this negative 0.472. X minus 0.3 plus 1.546. Done. The only thing we didn't get a chance to get to was this final part D. It was worth 1 little point out of the 9. Okay? This is pretty much how we're going to spend the next 3 weeks. Some amount of time with the survival guide, some amount of time where I'm focusing on the thrills with the 3, and usually ending with you guys doing one of the much harder parts.